Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. In this episode, we're going to look at IPv6 address types. We'll be discussing Unicast, Multicast, Anycast. We're going to look at the IPv6 prefix length, types of IPv6 unicast addresses, IPv6 global unique addresses, global routing prefixes, subnetting ID, interface ID, and then finally we'll take a look at the IPv6 link local address. This episode is part of my series on Introduction to Networks for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. As we look at IP version 6, there's three broad categories of IP version 6. There's Unicast, Multicast, and Anycast. A unicast address uniquely identifies that device on the network. It's for one-to-one communication, one device to one device. This is very similar to IP version 4 in the IP address you would get there. Multicast is the same as an IP version 4. It's when a device sends out a message and it goes to all devices on that local area network. One to many, that's the multicast device. IP version 6 adds in a unicast address. What a unicast address is an address that can be assigned to multiple devices, and when a message is sent to that address, it's sent to the closest device with that address. Routers use this for routing protocols to determine best routes, processes like that. There is no broadcast address as such as there was in IP version 4. IP version 6 does not use that. IP version 6 prefix length. The prefix length, or the slash notation in IP version 6, is very similar to that slash or subnet, or the subnet mask in IP version 4. It identifies the network portion of that IP address. Typically, it's a slash 64. That's what we recommend for most LANs, but it could range all the way from 0 up to 128. It could be no bits long, or it could be all the bits in that 128-bit IP version 6 address. Typically, we say use the slash 64. It's used by the SLAC process, the stateless address auto configuration, because that uses it. They recommend you should use it. Just match up all those prefixes together. And in today's world, with IP version 6 having so many addresses, we typically just use the slash 64 right now. IP version 6 typically has two unicast addresses. IP version 4 only had one. That was the normal IP address that we went and we entered in the interface in your PC. That was the unicast address. Typically, IP version 6 has two of those unicast addresses. One is the GUA, or the global unicast address, and the other one is the link local address, the LLA. Those are two unicast addresses that IP version 6 typically has. Some thoughts here about that unique local address. The unique local address, it starts with a range of FC00, and it's got a /7. No, it's a /7 and not a /8. And then that goes up to the FDFF, the first hextets again, and that's also a /7. It's the first 7, not the first 8, and that's going to be important here in a little bit. It's similar to those IP version 4 RFC 1918 private addresses, the 10.net networks, the 172.16 networks, and the 192.168 networks. It's similar to those. These local addresses can only be used on your local network or within a limited number of sites. You can set up a limited number of sites to use those local addresses, but typically it's just within your LAN, your local area network. You use these on devices that will never need to access another network. And most devices on your network don't ever have to access another device. What they do is they access the default gateway. The default gateway then accesses another network. So all their conversations stay on the network. IP version 6 unique local addresses also are not routed or translated to a global IP version 6 address. They stay local. If they happen to hit an internet router or device on the internet, that device will drop, delete, that local address. I hope you're liking this episode on IPv6 address types. If you have the time, please leave a comment and let me know what you think about IPv6 address types. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. The IPv6 global unicast address. This is globally unique. What that means is there's only one device in the entire world that's going to have that address. It's globally unique. If another device has that address, there's something wrong, and the administrators need to find out why that is. But only one device will have that globally unique address. It's routable across the entire internet. That globally unique address, it can go out from your default gateway to your ISP across the internet all the way to its destination. It can be routed that way. Currently, right now, only the global unique addresses that start with a hexadecimal of 001 are being assigned. And so if you look at it, it's the first hextet is 001. And if you translate that into decimal, that's starting with a 2 or 3. Down here, you can see that for our global routing prefix right here, we started with the 00. And so we have the range of 00 here, 001, 001, and then we have all zeros and all ones. If you turn that into decimal, we have 2000 and 3FF. Basically, it starts with a 2. Basically, it starts with a 2, ends with a 3 right now. Those are the only ones being assigned by those organizations out there that assign IP addresses. As we look at this global unicast address, there's typically 3 parts to that. The first part here is the global routing prefix. What this global routing prefix is sort of the identifier of your company, the identifier of your network. This says that anything matching this global routing prefix belongs to this organization. Then that organization can choose to use different subnet IDs. You can create smaller networks within this global routing prefix. And then the last part here, this interface ID, that is to identify a device on your network. It's unique to that device on the network. The IPv6 local link address is to communicate only with other devices on that same network, on that same subnet. Packets with a source or destination link local address, they can't be routed. They can't go out onto the internet. If an internet device gets one of those, they drop those packets. Every device that uses IPv6 must have a link local address assigned to it. If it's not configured manually, it will be automatically created. There's a creation process that automatically does that. Currently, right now, the IPv6 link local addresses are in the FE80, meaning the first hextet is the FE80/10 range. Now, down here on our network, it has a diagram. We got a couple routers, and then there's a PC that's connected into it. As we can see here, the link local addresses are only unique in this network when I'm circling. I'm circling here the interface on the right router, the interface on the left router. It's only on this network. This is a separate network over here to the right of the right router. And that interface that connects to that network, that's on there. In theory, this could have the same address. So here's an example, FE80::1 is an example here of one of these link local addresses. We could assign the same address to both of these interfaces on this router. So this router would have link local addresses of FE80::1 on both of its interfaces. But We can do that because each of these are connected to a different network. And so for the network on the left here, they use the link local addresses to send routing updates and figure out what the best routes are for these routers. The network on the right, hosts use the link local addresses to figure out information about the network, the default gateway, the network address, and the prefix or the slash number that way. It was my pleasure to provide you with this wonderful episode on IPv6 address types. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. In the upper right is my playlist for my series on Introduction to Networks for the CCNA. In the bottom right is one of my favorite videos that I picked just for you. Thank you so much for watching this episode on my series on Introduction to Networks for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.